Gate channel. And guys, yes, I right that 10:30 session I was in my home, but right now I'm in my office, and I thank all my team, community team, and especially video team, those who have planned this session and make the setup so fast, guys. Okay, so it's a team effort. Yeah, of course, always I said that in front of camera you are seeing only me. Okay, Abhinav sir, but backhand, the video team, community team, everybody is doing with 100% efficiency, guys, day and night, every time. So guys, share the session with everybody so that more and more commandos can join in and have a blast here, guys. Okay, so yesterday what we have done, guys, yesterday we have done, guys, stress and strain, in which we have done thermal stresses, Poisson ratio, deformation of bars, stress strain curve, properties of material like elasticity, toughness. Then we have done SFD BMD, the AN method. Then we have done, guys, the bending stresses, the flexural formula, and then, guys, we have done shear stresses. Okay, so guys, now today okay, today we'll be doing, guys, transformation of stress, torsion, deflection, strain energy method, pressure vessels, thin and thick shells, and spring, column, Euler's theory, Rankine's theory, every remaining part will be doing today. So how is the Josh commandos, everybody? And guys, literally I will please share the session. I don't want that anybody saying is missing the session because of that thing. And yes, guys, there are more other sessions today as well, like evening Joshi sir will be taking FM2. Then there is a Menti session in this channel, and Hindi channel, MSQ, that the whole team, the content team is preparing from last 45 days. The MSQ design question, because there is no book available for MSQ till now, no standard book available. So the whole team has designed the MSQ questions from last 45 days. That session is for all civil engineers, 8:15 p.m. in the Hindi YouTube channel, guys. Please subscribe to the channel so that the YouTube is pushing you the notifications and suggestions, so that no such planned session where whole effort has been done will be missed by you. Everybody. Okay, Mansoor Ahmed is saying it's snowing here. Mansoor Ahmed, where are you? I guess Kashmir. Suraj, R. Patel. Somebody's name is a boy without hurt. Okay, Mudassir, how are you? Okay, Medan, everybody, Dikshit, good. Okay, from Andhra Pradesh. Okay, so guys, let's start the session, everybody, and I'll sharing the link as well, guys, in the Civil by Abhinav sir. Okay, so Joshi sir is here as well, guys, in the office. He is also right now in the office only. Guys, my name is Abhinav Negi, having 9+ years of teaching experience. Done my MTech from IIT Delhi in Geotechnical Engineering. Got All India Rank 164 in 2012. Mentored more than 20,000 students in offline for more than 8,000 hours. And these are my subjects. Right now we are doing with the strength of materials. Guys, everything, whatever I'll be teaching you, whatever I'll putting ink here, you will be finding in the Telegram Civil by Abhinav sir. Okay, whatever I'll be teaching you, will be finding the link in Civil by Abhinav sir, guys. Here the part 1 PDF yesterday I've shared. Just after the session, within the 5 minutes I've shared in the Telegram Civil by Abhinav sir. Similarly, part 2 also I will be sharing. These are the faculties that are regularly helping you in app or in YouTube classes. And guys, yes, this session has been started. And it is MSQ, and it is on Hindi channel, Hindi YouTube channel. Please subscribe that. And this will be 8:15 p.m. for today for civil and mechanical, and 9:15 p.m. for electronics. 8:15 p.m. guys. Okay, this is the schedule of guys, MSQ. You can take it screenshot also. I have shared this whole schedule in my Telegram as well, Civil by Abhinav sir. Okay, so how's the Josh commandos? Okay, KTK, I'm from the same place. Okay. Good morning, Teja. Every Visakhapatnam. Okay. I'm from Kashmir. Yes, Mudassir, I know you here. We have met in Kashmir. See, Mudassir is our student. And see, this relation is very, not only here, but also, guys, will be like Mudassir, you can say example. I have visited Kashmir with my family, I guess in the month of October. And Mudassir has messaged me on Telegram that, sir, are you in Srinagar? Yeah, I said yes. He was also there. Not in Srinagar, he was in nearby district. I forgot the name of that district. Okay, and from there he has come to visit me. So it was very nice meeting with him. Okay, Mansoor Ahmed is here. Excellent. Okay, excellent. Okay, now moving forward, guys. Yes, this session is today at 8:15 p.m. This session is today at 8:15 p.m. on Hindi YouTube channel, and this is at 5 p.m. FM part 2 in this English YouTube channel. This is 5 p.m. on English YouTube channel, guys. Okay. So my friends, this Maha Marathon, first of all, before going to the part 2 chapters like transformation of stresses, deflection, torsion, spring, column, pressure vessels, thin cylinder, thick cylinder. Okay, guys, first of all, let us have a revision. Everybody on the comment box, give me the answer. This is the revision of the part 1. Come on, chaps. Everybody, come on, come on. Which of the following material has highest Poisson ratio? Which of the material have highest Poisson ratio? Come on. The answer will be rubber. That is 0.5. That is 0.5. Guys, let me tell you all the questions that can be asked. All the questions that can be asked from Poisson ratio. Let me write everything here. See, if they ask Poisson ratio range for all substances in the earth, all substances in the earth, then the answer will be -1 to 0.5. Minus values are for human tissues and soap polymers, and 0.5 is for rubber. Okay, great, great. This is when the question is asked all substances. Suppose it asks all metals, engineering metals, then the answer lies from all metals, answer lies from 0 to 0.5. The maximum value is 0.5. Okay, so both questions has been asked by GATE. Okay, you have to check whether it is all substances is written or metals is written. Okay, because human tissue is not a metal, soap polymer is not a metal. And if it asks, that might be some of you not knowing, if they ask for ductile metals, then it ranges from 1/4, that is 0.25, 0.25 to 0.3. Okay, so these 3 questions can be asked for mu range in any exam, might be GATE or any other exam as well. So you have to check what is the range. It is asked for substances in the earth or metals or ductile metals. The fact, many of the students who are visiting all the sessions will get 60 plus, 70 plus. Many of the students will not get that much benefit. That depends on how much you are grasping the things. And to be very frank with you all guys, only seeing me, only seeing the classes here will not get you marks. Of course, whatever the PDF we are sharing you, and apart from the classes, you have to do the homework as well. You have to do your own practice as well. Only seeing me will not do the help. Okay, this question, area under the stress strain curve represents. Okay, let me derive this. Everybody might be knowing answers, but let me tell you so that every time in this universe you will be knowing the answer. Every time you will be knowing the answer, I will be teaching you this in 2 minutes like this. This is a P delta curve, this is strain energy curve. Might be linear or whatever is the curve. Can be linear, cannot necessary to be linear. That depends on metal to metal. Okay. See here guys, everybody. Suppose this is a body, in this body like this, and I am applying a P force. I am applying a P force on this, okay? Please see this. And with the application of P force, the elongation is delta. Okay, so is a deformable physics. Here there will be deformation. So what is the work done? What is the work done, guys? What is work done is force dot distance. Okay, so force dot distance, if you think P dot delta, it is wrong. It is wrong. It is wrong. Okay, the work done is force into distance, but force is P/2. How, sir? Into distance is delta. How, sir? How, sir? P/2, sir? This is the revision of part 1. Then we'll be going to part 2. How, sir? P/2? How, sir? P/2? Guys, because in SOM there are certain assumptions that are valid for each and every chapter. First one, guys, that material is homogeneous, isotropic, follows unless mentioned it will be weightless, follows Hooke's law. These are assumptions. And one more assumption, that all loads are static load. All loads are static load. That means whenever you are seeing a P load, that is static, gradually applied, means suddenly the P load has not been applied. It is 0, then bit more, then bit more, then bit more, then P load. So load is applied gradually, 0, more, P. Okay, so that is gradual load. By default, SOM assumes everything to be static and gradual load. So 0, little bit more, and then P load. So what is the average for the whole delta? For the whole delta, what is the average? For the whole delta, what is the average? What is the average? Average is P/2. Average is P/2. Got it or not? Everybody, please let me know. Have you got it or not? Everybody please let me know on the comment section. Everybody please let me know in the comment section. Have you got it or not? Okay, so for work done is force into distance, that agree. But work done is force into distance, but force is P by 2. Force is P by 2 because the load is gradually applied. Okay, excellent, got it. Everybody, let me mute the laptop, otherwise many notification will be coming and my mind will be disturbed. Okay, so guys, what is the area under P delta? What is the area? This area is half base into height, so half base into height. So area under the P delta is strain energy. Work done is strain energy. Okay, work done is stored as strain energy. So area under the P delta curve is strain energy. Now what is sigma? What is sigma? Sigma is P by area. What is strain? Strain is delta by L. Strain is delta by L. Strain is delta by L. So here this area, it will be again half base into height. So delta by L base into height is P by A. So it is half P delta. Half P delta is strain energy and area into length is volume. So this is strain energy density or strain energy per unit volume, guys. Might be many of you for whom this derivation is very new. Please let me know in the comment section. Because, sir, why you are deriving, sir? Only take the A answer and go forward, sir. Why you are deriving, sir? Because now after this derivation, this concept is forever in your mind. Whatever things, guys, you have learned with concepts, that you will not be forgetting. Whatever things you learned with concepts, that you will not be forgetting very easily. Okay, now you understood this concept, you will not be forgetting. With one revision, you will understand it. Everybody, please let me know. Because a boy without hurt, because when you, there is a variation from 0 to P, okay, so average will be, of course, initial value 0, final value P by 2, not P by 4. Okay, suppose you got in one subject 10, another subject 20, 30, 40, 50. So average will be not 10 plus 50 by 4. Okay, got it, guys, everybody? Please let me know in the comment section. Have you understood the concept now for this? Okay, now next question. A material is said to be perfectly rigid if its modulus of elasticity, that is Young's modulus, is how much? Come on, let me know in the comment section. What is Young's modulus? Everybody, please let me know, friends. Please let me know, friends. Have you, come on, guys, give me a reply. Everybody. Everybody. Guys, Young's modulus is stress by strain, and rigid means strain is 0. Rigid cannot be elongated. So Young's modulus will be infinity. Next question. Everybody, come on. To ensure constant bending moment over a beam segment, the shear force acting on the beam segment should be yesterday's revision, guys. Come on. Yesterday's revision. Soon we are coming to today's class, guys, then. After the revision. Guys, see. Everybody. Bending shear force, V is shear force, huh? So V is equal to dm by dx. Yesterday I told you. So M is constant. If this M is constant, then shear force is 0. Then shear force is 0. Got it? Great. For a cantilever beam, maximum tensile stress will be induced in, come on, guys, this is a cantilever beam. Let me draw it here. This is the cantilever beam, and on this cantilever beam, guys, downward UDL is acting on it. Okay, so where this will be deflected like this? Anybody can tell. So tension at the top and compression at the bottom. If I draw the cross section like this, little bit bigger, so it will be tension here, compression here. So where it will be maximum? Extreme fiber above neutral axis, below on the neutral axis, constant throughout the cross section. Maximum will be above because it is downward, it is hogging. Got it, guys? Satnam, Varsha is on, Grishma, everybody, great. Guys, please like the session so that more and more commandos can join in here. Please like the session so that more and more commandos can join in. Come on. Come on. This one, guys. Everybody. Please let me know. Please let me know. I already told you, please take a copy calculator along with you. And this is my link for evening 8:15 p.m. This is my link for evening 8:15 p.m. guys. MSQ of SOM and OCF. Yes, welcome Arna. Please like that link, everybody. Now see, the deflection of point B is asked. Okay, first of all, the most important word, many times the question has been asked in GATE, telling you also this is rigid. Whenever the word is rigid, that means that it cannot be like this. No, rigid cannot bend like this. Rigid cannot bend like this. No. Okay, rigid cannot bend like this. Okay, so a warning I am giving to, hello Ritu, a boy without hurt. And Medan, please use English language so that everybody can get your comments. I don't want any other language here. Even my language of Uttarakhand also I don't want here. Okay, so let it be whatever you are asking doubts or you are conversing in between both of you. Let it be in English, guys. Thank you. So, this is rigid, so it cannot bend. Yes, but of course it can go like this. So, if here deflection is delta, so here deflection will be 2 delta according to similar triangle. According to similar triangle, this length is L, this total length is 2L. So this will be delta and 2 delta. Okay. So here the force will be coming F and that will be 500. So summation of movement about A, if I make it 0, that is a hinge. So 500 into 2L is clockwise and F into L is anti-clockwise. So net movement is 0. That is a hinge. 500 into 2L and F into L is equal to 0. So L to L cancelled. So F will be 1000. So deflection there delta is equal to P by K or F by K. So that will be 1000 by 50. So that will be 0 to 0 cancel. It will be how much? 20. So delta is 20. So then the 2 delta is here is 40 mm. This is 20. So where B is asked. So 40 mm downward. Got it or not, guys? Thank you, boy without heart. Okay, come on, guys. Let me know how is the Josh, guys. And please like the session so that more and more, guys, 100 people are watching here. Only 60 likes. What is this here? Come on, guys. Everybody. Please let me know. A is hinged, yes. Now number of independent and not wasting time here. No, your time is 2. For isotropic it is 2. For ortho it is 9. For anisotropic it is 21. This one, come on. 100 kilonewton force is applied on A plate. Shear stress developed in the rivet will be. Everybody. Please, suppose here is this 100 on A plate. Rivet is attached, so it is in equilibrium. So here is 50 applicable because it is symmetrical, and here is 50. Here is 50. Getting or not? Okay, leave. Shear stress is asked. Okay, if you don't want to understand like this, answer will be 50. Okay, not answer will not be 50. If you don't want to like this, can anybody tell me? Let me see here who can reply this very fast. Please see, friends, if I make this rivet, let me make this rivet. Twing, and twing. This is a rivet. So this is 100 kilonewton applicable here. So here, if I cut it, so cutting this section here, so it will be pushing by 100 here. Getting or not? If I cut this part, see which part? This part. I'm zooming this part. So this part is something like this. I'm zooming that part, huh? I'm zooming that part, huh? I'm zooming that part, huh? Which part? Which part? This one. This one I'm zooming. Okay, this one. So here in this zoom part, here the force is acting how much? It is pushing it here 100. Since it is in equilibrium, it is symmetrical. Since it is in equilibrium, it is symmetrical. Nobody is giving the answer here. Come on, friends. Come on, friends. Since it is in equilibrium and symmetrical. So 100. So for balancing, here is how much coming? 50. It is balanced and symmetrical. So 50-50. So here the force is 50. Now, if you see this like this, so here is 100 and 50 is here. So what is shear stress? Nobody giving the answer. Shear force is 50. Shear force is 50. What they asked? Shear stress. What they asked? Shear stress. So shear stress is shear force by area. 50 by area. Area, this 50 is in kilonewton, let it be Newton. 1000 Newton. Area is pi d square by 4. D is how much? 20 mm. Pi into 20 square by 4. This answer will be in Newton per mm square. Newton per mm square. Everybody, have you understood the concept? Everybody, have you understood the concept? Please let me know. And that is the link of the MSQ today. Please share that link, like that session as well. Please like that session as well, so that you will get the MSQ that is designed by our team from last around 1.5 to 2 months. Any doubt, guys? Please let me know. 159.14. Okay, great. Great. 159.14 Newton per mm square. Great, guys. Guys, please like the session so that more and more commandos can join in. So you are saying here to be 159. They have asked 159.14 Newton per mm square. Okay. Now, guys, see. This we have done part 1. This we have done in part 1. This we have done in part 1. Now the topic for today will be these. Are you ready with me? Please bring your copy, pen, everything with you. This is part 2 today. And let me tell you, part 2 is a bigger syllabus in terms of, you are seeing that number of topics. In terms of number of topics, it is bigger syllabus, guys. But in terms of time, it will take less time. Okay, because the high weightage, okay, where the more number of questions is asked, this will be like this. Getting or not? Okay, great, friends. How's the Josh, guys? Ready for today's session? Earlier we are doing only the recap. Are you done? Are you ready now, guys, for the session? Are you ready, guys? Let's start today's session, everybody, with transformation of stress chapter. See. Everybody, see, guys, whenever there is a body like this, yesterday you gave me a heart attack and P force is applied on this. Okay, sir, got it, sir. And here is the ground. Okay, sir, got it, sir. Here will be the reaction P. I asked you yesterday, sir. That what stresses are acting on this body. Many of you, apart from 5 to 6 names, everybody says normal stress. Okay, everybody say normal stress. But guys, I told you yesterday, if this is a plane XX, on XX plane, sigma XX will be there, but shear stress will not be there, because the force is perpendicular to that. But if the plane is YY, on this YY plane, I told you yesterday as well, here is the P force. P will be having two components, P1 and P2. P is the father, the two sons will be P1 and P2. Two sons will be P1 and P2, and sigma YY is equal to P1. P1 is perpendicular to that, na yaar. P1 is perpendicular to that, na. P1 upon area of YY. And shear stress on YY plane is equal to P2 is tangential, na. So P2 upon AYY. So on x plane there is no shear stress, but on y plane there is shear stress as well. Guys, how many planes are in this body? Infinite. How many planes are in this body? Infinite, guys. Infinite planes are there. Okay, and infinite planes will be having infinite normal stresses and shear stresses. Infinite planes will be having infinite normal stress and shear stress that we will be finding in this chapter, that is called transformation of stress. Many will say the name is principal stress. That is wrong, yaar. Principal stress is just one stress where the stresses are maximum. Okay, the actual name of the chapter should be transformation of stress. Okay, so this is transformation of stress, guys. Okay, now on there are 2E plane, Z plane, alpha plane, beta plane, 30-degree plane, 31-degree plane, 32-degree plane, 35-degree plane, 38-degree plane, 41-degree plane, 43-degree plane, 47-degree plane. There are many planes, or in many planes there are many stresses that we are finding here. Out of those infinite planes, guys, out of those infinite planes, one plane will be having maximum normal stress and minimum normal stress. That is called principal stresses, and they are represented by sigma 1 and sigma 2. Again, I am telling you, out of the various planes, 30-degree plane, 31-degree, 32-degree with this vertical axis, 33, 35, 38, 42, 45, 128. Out of the various planes, one plane will be having maximum normal stress. That is called major principal stress. That plane is called major principal plane. Out of the various planes, one plane will be having minimum normal stress. That is called minor principal stress. And on which that stress is acting, that is minor principal plane. And those are at 90-degree. And guys, on maximum normal stress and minimum normal stress, that is major principal stress and minimum principal stress, shear stress is always 0. There is no shear stress. And that are random stresses, sigma x, sigma y, tau xy, because tau xy is not 0 there. Not 0 means that are ordinary stresses, not maximum, not minimum. And sir, if this is tau xy, yesterday I have done derivation, this is tau xy, this is also tau xy, this is also tau xy, this is all tau xy. I hope you remember, opposite phase are equal due to, this is tau xy, this is also tau xy. Opposite phase are equal due to, opposite phase are equal due to force equilibrium. Opposite stresses are equal due to force equilibrium, and adjacent are due to movement equilibrium. Remember or not? Remember or not? Yes. Everybody, please welcome one of my greatest friend, dearest friend, Mohit sir. Please put a heart sign. Please put a heart sign from him. Okay. One of the very intelligent guy. Okay. Everybody. Yes. Great. Okay. Now, sir, guys, case 1 is nothing. With case 2, I will derive case 1 also. With case 2, don't remember these formulas. Okay, because they are applicable only when principal stresses are given. I will tell you general formula that is applicable everywhere. Guys. See, everybody. Okay, see everybody. Suppose this is a body, a point in which here it is acting stress sigma x. Okay, sir. Here it is sigma y and here is tau xy. That is given. Something like this is a body. Here some 20 Newton per m square stress is given. That is sigma x. And sigma y is given 30 Newton per m square. That is sigma y. And shear is equal. If this is 25, this is also 25. Yesterday I done the derivation. This is also 25. This is also 25. That is tau xy. All are equal. So sigma x, sigma y and tau xy is given. Sigma x, sigma y and tau xy is given. This will be given to you, and they will ask something values like 20, 30, 25, 70, 90 will be given. Okay, sir. And they will ask you at a inclined plane with theta. Suppose this is the plane. Let me just orient this. What is this? This is not below. This is here like this. This is here like this. Okay. So suppose, and this plane, if the body is oriented like this, what is sigma x dash? What is sigma y dash? And what is this shear stress? All are equal. What is this tau x dash y dash? That are given by this formula. And why I have told you not to do the first formula? Because in second formula, if you put tau xy 0, that will be only the first one. First one is applicable when we know the principal stresses. Okay, so only remember second. If there are principal stresses, shear stress will be 0. Hide this, then this will be case 1. No need to remember case 1. Okay. So here the stresses are sigma x dash, sigma y dash, tau x dash are given by this. Okay, sir. Sir, what is the value of principal stress at, and sir, this is the stress now, okay? At which angle we'll get the principal stresses? So we will get principal stresses. Please see the derivation just in 2 minutes. Principal stresses we will be getting. Principal stress or principal plane we will be getting when shear stress is 0. When shear stress is 0. When I rotate 10 degree, 20, 12, 22 degree, 25 degree, 28 degree, at what shear stress will be 0? At what shear stress will be 0? Then guys, we'll be getting principal planes. So minus sigma x, soon I am coming to the questions as well. Sine 2 theta p plus tau xy cos 2 theta p. Why I am writing it theta p? Why I am writing theta p, guys? Because this is the plane of principal plane. That's why I am shear stress is 0. Shear stress is 0. Divide by cos, you will get simply, within the next step, you will simply get, not wasting the time in calculation, 2xy upon sigma x minus sigma y. This is the angle of principal plane. If one plane is 30, another will be 120 because two principal planes are 90 degree away. Two principal planes are 90 degree away. Two principal planes are 90 degree away. Okay, so whatever theta you will getting here, another will be at 90 degree away. Got it, guys? Everybody, please let me know. Please let me know, guys. Have you got it or not? Yes. Okay, sir, we got here the angle of principal. At which orientation we'll get the principal plane? And now, if I put this angle, theta p here, then the stresses we will be getting will be not the ordinary stresses. They will be the stresses of principal stresses. Guys, see, we get the angle. Suppose let us say 30 degree. At 30 degree we get the principal plane. So if we put the angle here 30 degree, those normal stresses at 30 degree will not be the ordinary, they will be the principal stresses. And what we got, sigma 1 slash sigma 2 is equal to sigma x plus sigma y by 2 by putting this theta here, plus minus, plus for major principal stress, minor for minor principal stress, plus minus sigma x minus sigma y by 2 whole square plus tau xy square. This will be getting the principal stresses. This is not divide, this is slash. For one it is plus, one it is minus. Everybody please let me know. Have you got it, guys? Have you got it? Just put a heart sign on the comment box if you got it, guys. And everybody please like here. 120 people, 115 people are watching. Only 88 likes. Come on, guys. Everybody please put a heart sign. Have you got the concept or not? Have you got the concept or not, guys? Please let me know. And one question to everybody I want to ask you here. Suppose suppose the Mohr circle is, let me first of all tell you Mohr circle. Okay, let me tell you Mohr circle first. This is analytical method. Then I'll ask you that interesting question. So this is analytical method. Analytical method means with the help of equations we will be finding stresses on different planes. Different theta, different stresses. Different theta, different stresses. Okay. Now, yes, under root. Now, graphical method. See, let us draw a graph. On x-axis I am putting sigma, on y-axis I am putting shear, on tension is normal tension stress on positive and compression here. Okay, and we'll get a Mohr circle. Center can be here, can be here, can be here, can be here. Let us, I am randomly drawing the center is here. Okay, center can be here as well. What is the center? What is the center? Sigma x plus sigma y by 2 comma 0. What is the radius? Radius is sigma x minus sigma y by 2 whole square plus tau xy square. Okay, wait. Guys, if the body is like this, 30 and 10. So what is center? 30 plus 10, 40 by 2. That is 20 comma 0. Center will be on right hand side. If the body is like 20 and this is 30 here, 30 here. What is the center? What is the center here? Sigma x plus sigma y by 2. So one is plus 30 tension, one is compression minus 30. So it will 0 comma 0. Center will be here. And suppose this value is not 30, it is 60. So center is sigma x, that is 30 plus sigma y is minus 60 by 2 comma 0. So center will be here in this case minus 15 comma 0 on left hand side. Center will be on left hand side in this case. Got it? Got it, guys? So center is not necessarily always on the right, it can be left as well. Center is not always on the right, it can be left as well. It depends on sigma x plus sigma y by 2 is coming 0, then it will be here. Or if it is coming plus, then it will be right hand side, it will be here. minus, it will be left hand side, and it can be like this as well. Center is here, but radius is so much that it can come here as well. Okay, so any shape can be made. Okay, now suppose somebody has given you, let me just take a random value. Somebody has given you the values like this is let me make a good value so that it will be easy for you. It will be 110, it will be 30. Wait, yaar, let me make a good values na, so you'll understand the things better. And it will be 30. So what is center? What is center? 110 plus 30. Oh, sorry, minus 30. It is compression. 110 minus sigma x plus sigma y. 110 minus 30. It will be how much? 80 by 2. 80 by 2 is 40, comma 0. So center will be 40, comma 0. Getting or not? Yes, getting. Yes, getting. What is radius? What is radius? Sigma x minus sigma y by 2 whole square. So 110 minus sigma y. It will be 110 minus sigma y is how much? 110 minus sigma y is how much? It will be, let it be, let it be making it, let it be making it, let me make nice values. This will be suppose 50 and this will be 30. No, then also it will not be coming great. So this will be 50, 110, okay, and that is I have made 30. So 70 square, okay, let it be any value here. Okay, usme it will be wasting time in making good values. So it will be 110 and it will be, let it be 30 only. So here the radius will be 110, this is 110, this is 110 minus 30, that is 40, comma 0. Radius will be sigma x 110. Sigma x is 110 minus sigma y. 110 minus 30. 110 minus 30. It will be how much? 140 by 2. 140 by 2, that is 70 square plus tau xy square. Tau xy is how much? 30 square. So whatever is this value, radius will be coming like this. Okay. Okay. Now, sir, what are there? How many points are there in this? How many points are there in this? In the circumference, infinite points. In circumference, there are infinite points, and in every point is having a coordinate. Every point is having a coordinate. Every point is oh great, 76.16. Okay. Every point is having. Now I'm drawing for any random value. Every point has a x coordinate and y coordinate. Agree or not? Every point has a x coordinate or y coordinate. Agree or not? So x coordinate will represent normal stress and y coordinate will represent shear stress. X coordinate will represent normal stress and y coordinate will represent shear stress. X coordinate will represent normal stress, y coordinate will represent shear stress. Okay, so there are various planes in this body. On these various planes, what are the normal and shear stress that are given by these points? That are given by these points. That are given by these points. There are infinite points on the circumference of the circle. Every point, there are infinite points. Every point is having x coordinate and y coordinate. X coordinate will represent normal stress on that plane. Y is shear. See guys, now out of these various points, see this one is maximum na. This is major principal stress. See, on major principal stress, shear stress is 0. And this is minimum na. This is minimum na. On minimum C, shear stress is 0. On minimum C, shear stress is 0. So maximum and minimum shear stresses are 0. Maximum and minimum shear stresses are 0. Maximum minimum shear stresses are 0. And guys, see, diameter radius can also be written as sigma 1 minus sigma 2 is diameter by 2. Sigma 1 minus sigma 2 is diameter upon 2. Guys, what is tau max? Out of the various points, which is having maximum shear stress? This one. So tau max is also radius. What is the tau max? Is also radius. Have you got it, everybody? Have you got it, everybody? Please let me know. Please let me know. On the comment section, any doubt? Any doubt to any of my friend? Any doubt to any friend? Okay. Practical situations we can make, na? Practical situation also we can make. Okay, suppose you want to find the angle from principal stress at 30 degree. Some principal stress is given and they ask you the find the value at 30 degree. So from principal stress go here at 60 degree, because Mohr circle every angle is represented by double the angle. See, angle between principal planes is 9 degree, but here it is 180 degree. Okay, so suppose somebody asks you that from 30 degree from principal plane find the values. So instead of going 30 degree here, go 60. Whatever the values will be giving, that will be normal and shear. And from geometry you can do it. Okay, from geometry you can do it. Everybody please let me know, have you got it or not? Okay, now guys, suppose there is a body having a pure shear. Now my question is not like this. No. Everybody knows, sir, for pure shear, if this is tau, this is tau. Sir, my question is not like this. I can ask you principal stress is no. I will ask you center, no. I will ask you radius, no. That I will tell you. I will ask something different, new question. I will ask something new question to you. Because everybody know, if this is pure shear, what is center? Sigma x plus sigma y by 2. No sigma x, no sigma y. So 0 plus 0 by 2, it is 0 comma 0. Center will be here. Now radius is equal to sigma x minus sigma y by 2 whole square, that is 0 plus tau x y square. So radius is equal to tau, because sigma x and sigma y is 0. So radius tau means like this. Radius tau means like this. So this sigma 1 comes to be plus tau, sigma 2 comes to be minus tau. This everybody knows. One time in 2020 also the question has been asked. This everybody knows. Now my question is something different. This everybody knows, yaar. These are the most common question. Most common question is this. Like most common picture in set max. Can you tell me? In set max, what is the most common picture? Mostly they start that picture on the set max channel. Can you let me know if you see that channel? Even I don't see the movies. If I don't see the channels, then only I know. Okay. Now my question is, if this is a simply supported beam having UDL, cross section is rectangular. Okay, most common picture is Suryavansham. Similarly, the most common chapter here is most common question is this. Like there's Suryavansham there, here is this. Now friends, I want to ask, where in this beam, where pure shear comes? Where, at which point pure shear comes? Which point? Is it 1? Is it 2? Is it 3? Is it 4? Is it 5? Is it 6? Is it 7? Is it 8? It is at the center. This is exactly at the center. Is it 9? Is it 10? Is it 11? Where the pure shear comes, exactly the pure shear case is coming. Please let me know, friends. Exactly the pure shear case is coming at which point? 1, 2, 7, 8. Here let it be 11 tak ho gaya tha, 12, 13. Please let me know. Please let me know. And these 3 and 5 and all are at center, This 3 and this 5, all they are at center. This is neutral axis. Can you please tell me? Pooja is saying one. Multiple MSQ question, guys. MSQ, everybody, let me check. A very intelligent student can give the answer. Very intelligent student can give this answer. 1, 2, 7, 8 you are saying. Okay. Let me eliminate the options. 1, 2, 7, 8 can't be option. Why? Because shear stress is 0 at the top and bottom. There is no shear stress. 1278 cannot be there. 1278 Suraj cannot be there because shear stress at top is 0. And that is bending stresses. Shear stress at top is 0. There is no shear there. No shear there. 12, 3, 10, 5, 13. 12, 3, 5, 13. Okay, Namani. Okay. 10 also Vivek you are saying. See Vivek and Aman good. Varsha also good. Vivek, Aman, Varsha very good. Your answer is not correct. Your answer is not correct, but I am very impressed with you. Same with Ritu Lamba. Ritu Lamba, I am very impressed. Literally, I am very impressed with you. Same Swap, same Lavanya. Those who are saying 12, 3, 10, 5, 13, I am very happy. Literally, I am very happy with you. Literally, very happy with you. 12, 3, इसका खींच दो. 12, 3, 10, 5, 13. Very happy with you, but our answer is not correct because the shear force diagram is like this, and exactly at this point shear stress is 0. So the tau is equal to SAY bar by IB na. The shear force is 0 there. Shear force is 0 there. That's why 10 will not be there. 10 will not be there. At 10, see, at these points no bending stress will be there. No bending stress will be there. MS Dhoni is saying I am your big fan. I am big fan of MS Dhoni also. So at this point, no bending stresses will be there. That is correct. But at this point, at 10 shear force will also be there. 10 will be like this. 10 point will be like this. Nothing. No bending stress because it is neutral axis. No shear stress because shear stress is originated by this father S. S is not there. S is not there. Okay. So the correct answer will be 12, 3, 5, 13 because all are neutral axis. All are neutral axis. And there is no bending stresses, but shear stress will be there. And one person has got it correct. Please let me, yourself will name you. Lavanya, I think was name, Mavanya and LMV, someone name was there. Please let me know who got it correct. Who got this correct? Who got this correct? Some Lavanya name was there. Abhinav, if you want to contact me, either contact me in civil by Abhinav sir telegram group of Desh, or you can mail me at abhinav.negi@getitup.co. So one person has got it correct. Who was he? Who was the name? Please let me know. And surprise person is calling to you now. Everybody who, one was 93456. No. 9 there is bending stress yaar. 9 there is bending stress yaar. Whose birthday is today? Whose birthday is today? My birthday is on August 6th. Come on. One person was correct. Oh yes, Nantha Kumar. Great. Rank आएगा भाई तुम्हारा. Rank आएगा तुम्हारा. Okay guys, now just for refreshment before going to the further, let me just give handing over the mic to Super Duper Ninja sir.
Hello everybody, how are you? So.
Keep like and sharing guys.
भाई हाँ फटाफट से just please like and share the session. Sir is taking the class and हाँ जी right. तो a quick announcement for amazing students. The first announcement is that we have another class of fluid mechanics, marathon part 2, and it is at 5 p.m. After that we have Minty session also, but before that on Hindi channel we'll be having MSQ class at 8:15. Abhinav sir will be taking the class of Sir Soman OCF, right? Yes. Soman OCF will be there for MSQ 8:15 Hindi channel, and then at 9:15 we are coming back with the Minty quiz. Are you ready for the Minty quiz? Please let me know, guys. There will be 2 teams that we are going to divide, and how we are going to divide. If you are old students, you know it. If you don't know, we'll let you know. That's in the same session. Another very important thing is that the subjects that we are going to take is obviously SOM and fluid mechanics, because these two subjects we have completed for you all, correct, in these 2 days. So we are going to take this session tonight. So please be there and do not miss them. Now, let's come to this subject, the marathon that we are taking. I hope you all are taking this marathon very seriously, because after the marathon, now you need to know whether you are getting something or not in your mind, whether you are retaining something in your mind or not, because you really need to retain all these things, correct? So for that, the best thing that you can do is you will solve the MSQ question, because there is no standard book for MSQ question till now. That is the only reason why we are coming up with this MSQ class. And in MSQ class, guys, you know, the best part about the MSQ, is with the help of MCQ, you will be able to find out only one question. Right? Only one concept will be required, correct? But in MSQ, you will be requiring multiple concepts, and you need to know more than what you need to know in MCQ. So please remember this. Okay, guys? Mintigo is 9:15, same channel, English channel pe will be doing. Okay? Come on, share kiya, like kiya. First, please, can you please tell me, are you enjoying the sessions? Quickly tell me. Abhinav sir is not here. Fatafat se batao. Are you enjoying the sessions? Like all these sessions that we are taking, Abhinav sir is taking, I am taking, and then tomorrow Rohan sir will be taking the class for you of steel. Fatafat se comment box mein give your love in your own way, the way you like it. Quickly send heart sign, say yes, say whatever, right? Telegram पर link send कर दो sir. हाँ, that we will do. That will definitely do. मैं भेज दूँगा आपको. Everyone will be getting the Telegram पे link. ठीक है. And रही बात आपके PDF key. So the PDF will be given to you today. I'll be giving you the PDF of complete. So the one PDF I'll be sending you, and that PDF will be containing of 140 pages. And in those 140 pages, you will be having the complete fluid mechanics. Correct? Hai? So that will be fine, right? Thank you so much, Masroor. Thank you so much. Thank you. All right. So Shubh is not enjoying. Okay. And MSQ session is English. No, MSQ will be in Hindi. MSQ session will be in Hindi, and rest everything will be in English only. Only MSQ is there, which is in Hindi. Rest your marathon sessions, your Minty quiz, that is going to be in English on this particular channel only. अब मुझे सच में एक बात बताना, किस को डर लग रहा है? How many of you are getting scared because you have very less time? Quickly tell me in the comment box. डर किस को लग रहा है? Those who are actually feeling that fear that we have very less time, the exam is near, you have done your tremendous amount of hard work entire year, but now only few days are left, and it feels like you have studied nothing, or maybe it feels like you should have studied more, or maybe it feels like I am super confident for this exam, but still there is this small fear that is there inside you. So are you feeling that fear? Please tell me when you're going to take Namami. We have actually like given you the schedule. You can check on the Telegram, please. Okay. So yes, the only reason why I asked this question is to show you all, to let you know that everyone is feeling that fear. Everyone is feeling that fear. Okay, I'll just tell you one very short story. So I used to dance in my college, as you know. If you are old students, you know. If you are watching me for the first time, by the way, my name is Joshit Singh, right? So I used to dance, and I also had a dance group in my college time. So I was in SRM, and we went to IIT Delhi to perform. Right, that was my first performance on the stage, and the audience count was 470. Audience count was 470. Someone told me that 500 seats are there, so around 470 people were there in the auditorium. Now, as soon as I went on the stage, first we go to the stage to do all the stage setup. Matlab, where we will start. Okay, in the beginning I'll be standing here. Then after 2 steps I will be go there. Other person will go there. It is called as stage setup. We all do before we perform. So I was doing that, and samne the seats were getting filled up. Right. So I was getting that fear. Exact fear that you must be feeling right now, and I also used to feel when I was giving the preparation, when I was preparing for the exam. And then my senior came to me, the 4th year student. I was in 1st year. He asked me, "Dar lag raha hai?" I was like, "Yes sir, dar lag raha hai, bahut zyada. I'm feeling that fear. I'm scared." He said to me, and I quote, "Mujhe bhi dar lag raha hai." After dancing, after doing these many performances, still I am having that feeling of, fear. And that fear is the only weapon that you will be having in your examination, because that fear always reminds you that you have actually done the amazing the required hard work for that particular exam or for that particular task. For me, it was dance performance. For you, it is examination. So right, that fear should always be there. That actually let you help. That actually reminds you have done something which is worth doing. Okay. So please don't worry if you are having that fear. Enjoy that. Okay, embrace that fear, because there must be someone in yourself only, in your group only, who must be feeling like कि अभी feel नहीं आ रहा. As the time is coming closer, abhi feel nahi aa raha, and that feel is not coming because of this reason only, because there is a lack in the hard work somewhere in the process. Okay, so always remember that if you are having that feeling of fear, let it be, it's okay. Today also, like when I enter or when we enter in any session na, we also have that thing in us. Today also, after taking so many classes, so many sessions, ki yaar matlab someday it happens. Yesterday only it happened with me. When I was starting the class of fluid mechanics, I was taking class on smartboard after months. I guess after technical class, I think I have took after 7 or 8 months. I was having that fear. How to handle the smartboard, how to handle the bigger camera, because there at our place, at our home, we don't have this setup. We have different setup, right? And that time, we know how to deal with all those things. But yahan pe, I don't know. So fear is okay. It's okay, right? Perfectly fine. Okay, so now I'll call Abhinav sir. And you guys can carry on with the properties of Mohr circle, right? So I hope you got my point and you will also remember this thing. Sir is wearing commando t-shirt also, by the way.
Commando t-shirt is like this.
Super, like Spider-Man used to wear na, his suit inside the clothes, same thing. Commando sir is also wearing.
From last 7 days, same t-shirt. Okay, without any bath, just like a ideal engineer. Okay, so guys, please share the session again with every friends. Let's start again. Okay, thank you for Joshi sir for cheering you all.
Thank you.
Okay, so I'll be telling you some tricks also. So please stay tuned. I'll be sharing the tricks as well that I told you yesterday. Please do this question. Thank you, Joshi sir. Everybody is saying. Okay, for the Mohr circle shown in the figure, which of the following is correct? Which of the following is correct? This is 2 megapascal, guys. This value is 2 megapascal. So that will be pure shear case because center is at 0. Center is at 0. That is pure shear case, guys. Okay. Shubh is saying Abhinav sir is best. I totally agree with Shubh. Totally agree with Shubh. Okay. Now some questions I will be giving you to homework assignment. Okay. Now come to the torsion chapter. And one more thing, guys. Whatever we have done for stress na, each and every equation, if we replace sigma by epsilon and tau by gamma by 2, each and every equation will be changed to strain also. Strain. Just everywhere where there is sigma, it will be epsilon x dash, epsilon x plus epsilon y by 2, epsilon x minus epsilon y 2, cos 2 theta plus gamma xy by 2 sin 2 theta. Similarly, gamma x dash y dash by 2 is equal to minus epsilon x minus epsilon y by 2 sin 2 theta plus gamma xy by 2 cos 2 theta. Okay. Mohr circle is also in the same way. Now let us come to the torsion. Everybody ready? See, torsion. Everybody see. Whenever I apply a torque, see, torsion is just like first chapter. Torsion is just like first chapter. In the first chapter, guys, when we apply a force P, then there will be a deformation. Similarly, in the torsion chapter, when I apply a torque, the cross section is like this. When I apply torque, A will go to A dash, B will go to B dash, C will go to C dash, D will go to D dash, and how much they have moved, that is twist, phi, twist. D has gone here, that is twist, that is phi. As here is P is causing delta in first chapter na, P is causing delta in the first chapter na, here torque is causing twist. Okay? Great, guys. Okay, so here I am applying a torque, so here is this twist. See, this is the twist. This is the twist phi. Okay? Now sign convention, guys, many people are very this on sign convention. Whenever the torque is like this, for a balancing, here the torque will be like this. Okay, and if that guys torque is something like this, if something is like this, then for balancing same torque should be here. Otherwise it will be rotating like a sugarcane juice machine. Otherwise it will be Mansoor Ahmed strain knows that is a particular chapter I have taken in YouTube. You can see that, and if some question is asked, you can ask me. Okay, so some torsion is applied like this. For balancing, torsion should be like this, opposite, so that it will be in equilibrium, because in SOM we are studying the equilibrium things, not sugarcane juice machine. Similarly, if torque is like this, then torque is like this, so balancing. Now guys, many times my writing, anything might be difficult to understand, so we will apply right hand thumb rule. We will apply right hand thumb rule. If somebody is brain Lara, Shikhar Dhawan, Saurav Ganguly, then also he has to apply right hand thumb rule, because one question has been asked to me in my offline class when I was to take offline class earlier, that sir I am lefty, so I have to also take right hand thumb rule? Yes, everybody has to take right hand thumb rule only. Okay, now what is right hand thumb rule? You apply the figure like this, curl the fingers along the torque, thumb will point the direction of torque. So represent this torque like this for easy understanding. Yes, I will cover, Aman. If this curl the fingers like this, thumb will be torque. Like curl the finger, right hand, not the left hand. Not the left hand. Curl the fingers around this, right hand will show you the torque. Curl the fingers around this, right hand will show you the torque. Like this. Okay, so this T is like this. For balancing, you can assume it to be force also for some time. For some time you can assume it force. If this is towards left hand, so balancing it should be right hand side. Now this one guys, curl the fingers along the torque. Curl the fingers along the torque. So this will be the direction of torque. So you can convert this torque like this. And if you don't want to curl here, it's okay. Just assume for a very few seconds that it is a force. To right hand side the T is this. So here the left hand side T will be coming. Otherwise if you curl the finger, it will be here. Okay. And if the torque is going inside, that is positive, considered sign convention. If it is outside going, it is minus. Now what is the torsion formula? See guys, it is same like bending formula, exactly same. If I apply a torque like this, like there was sigma na at y distance, so here shear stress at r distance from the center, like there was bending stress at y distance from the neutral axis, like there was bending stress at y distance from neutral axis, here is shear stress at r distance. Because torque is producing shear, yaar. Torque na, in this bottle, I am not compressing it, I am not elongating this. If I am applying a torque, I am not compressing it, not tensiling, I am providing shear. I am providing shear here. Okay. So, like T is providing shear, here M was the father. M was providing the bending stresses. Here torque is providing the shear stresses. There was I, here was IP. IP is polar moment of inertia about this axis. The polar moment of inertia, the moment of inertia is IP. Okay, suppose see, this is a body. These are transverse axis. Okay, if this is a body, these are transverse axis. I is pi d 4 by 64. And if there is a longitudinal axis like this, longitudinal axis, I about this is IP. And I about the axis which are passing through the plane is I. Simply I. Okay. So here the torque is about this polar axis. So I also we write about polar axis. See how realistic is the formula. Here bending is about this axis. So I also we write along that axis. So here is E by R. And here G, shear modulus, shear stress by shear strain. L is the length of shaft and phi is the twist. So from there, guys, we understood that shear stress is T by IP into R. So we understood one thing from very clearly from here. If R is going more, shear will be going more. That means if a section is something like this, then shear stress will be something like this. Then shear stress here will be something like this. As we are going away from the center, shear will be more. as we are going away from the center, more, maximum. So here it is maximum, tau max. If for solid circular section, I want to find tau max, so tau max is equal to, see here, T by IP. IP for solid circular section is pi by 32 d ki power 4. Not I, IP into R. So where is tau max? When R is max. So R max from center. From center, what is the maximum distance? Either here, it is d by 2. D by 2. So from here, tau max is equal to 16 T by pi d cube for solid circular section. Got it, guys? Everybody, just give me Y or N. Just give me Y or N in the comment section. And from here, guys, twist is given by phi is equal to TL by GIP. This GIP is also called as torsional rigidity. This GIP is also called as torsional rigidity. Everybody, please let me know, have you understood this or not? Everybody on the comment box, please let me know, have you understood this or not? Any doubt here? Any doubt here? Okay. Now power transmitted by shaft. I am now telling about the rotating shaft, like a sugarcane juice machine. So power transmitted by shaft is T into omega. Omega is angular speed. Angular speed is radian per second. Suppose a shaft is having n rotation per minute. So what is omega? Omega is angular speed per omega is radian per second. How much revolving per second? So if n rotation per minute, one rotation how much angle? 2 pi. One rotation how much angle? 2 pi. One rotation how much angle? 2 pi. So n rotation will be 2 pi n. One rotation 2 pi angle, yaar, 360. So n rotation 2 pi n angle, that is radian. It is per minute. So per second will be divided by 60. So omega you can replace by this as well. Any doubt, guys, here? Everybody, come on, like the session and share it with yaar, everybody. Getting or not? Any doubt? Omega you can replace by this. Okay. Now indeterminate bars is asked. Now I'm not going in derivation. Okay. Suppose here is T. That is length A from here, B from here. Then what is the reaction here at A support? What is the reaction here? So reaction here is TB upon A plus B. Not going in derivation. It is TA upon A plus B. You can remember it like this. Like in simply supported beam, na. This is P. This is A, this is B. So what is here? Reaction will be PP upon A plus B, and here it is PA upon A plus B. So same way here also. You can remember, relate it like this. Any doubt? Any doubt, guys? Okay. Now if bars are in series, then if I want to find out phi AE, then what is phi AE? Phi AE is phi AB plus phi B. This is very interesting. Everybody please see here. Like delta, see, this is same like first chapter, yaar. Come on. If I want to find out that some forces are acting on this. This is A, this is B, this is C, this is D. Some forces like this acting on this. So what is total delta? So delta AB plus delta BC plus delta CD. Similarly, total twist here will be phi AB plus phi BC plus phi CD plus phi D. And phi is equal to TL by GIP. Phi is equal to TL by GIP. Correct? Okay. Now, everybody, please see. After this, I'll tell you a trick. Of some. Now see, phi is equal to TL by GIP. GIP is torsional rigidity. Now, first of all, you are very confusing. What is plus, what is minus? Very confusing, yeah. Let us apply right hand thumb rule. Okay. Now curl the fingers, and thumb will be direction of torque. This is TA. Curl the fingers, right hand, curl the fingers. This will be TB. Curl the fingers, this will be TC. Curl the fingers, this is, many people will get confused here. Let me make it clear. This is white color used for eraser. That is the brain of engineers. असली इंजीनियर तो सिविल ही है, बाकी सब तो फालतू में परेशान है उठे. Okay, this is like this, TE. So curl the fingers. This is going from here to there inside the board. Coming from here, going inside the board. Coming from here, going inside the board. Curl the fingers. This will be TE. This will be TE. Curl the fingers like this. This is TE. Okay, and for equilibrium, we can assume it to be forces. TA is right hand side, TE is right hand side, and here it is TB and TC for equilibrium. Getting or not? Getting or not? Okay, getting or not? So one more special guest is now in the studio. Around 1 more hour, Namini. One more special guest, and that is not Joshit sir. Okay, just you have to reveal the name. Soon he will be coming after this revision. Now what is phi AB? Phi AB. See, what to do phi AB? Cut a section here like this. Cut a section like this. See from right or left, your choice. See from right or left, your choice. So right it is TA. Right it is TA and going outside. Right it is TA going outside. Going outside was minus. Going outside was minus. Going outside was minus. Okay. So minus TA. Length of that section, take it length of whatever AB. Or you can take length here L1 from here to here. L2 from here to here. L3 from here to here. L4 from here to here. So minus TA L1 upon G of that AB upon IP of AB. Somebody is saying TV will be on other side. Okay, no yaar. See right hand thumb rule. It is going from here to inside the board. From here to inside the board. From here to inside the board. So curl the fingers. This will be like this. Okay, somebody is saying Rohan sir, Rakesh sir. Okay, okay. Any more guesses? Or you are done? Lock kar diya jaye. Like this. Now phi BC. Phi BC now. Please see. Cut the section here like this. You want to see from right or left? Totally your choice. Totally your choice. Phi BC. Totally your choice. You want to see from right or left. So from right, let us see. TA going outside. So minus. According to sign convention, we have just discussed. TB is coming inside. So plus. So TB is plus and TA is outside. Into length, that is L2 upon G of that particular section. What is that? BC upon IP of that. Yes, getting it. Friends are getting it. My commandos are getting it. Okay. Now phi CD. Cut a section here in CD. Like this. See from right or left, your choice. From right, there are too much. So left it is easy. So from left, let us see. TE is coming inside. So plus into length of that L3 upon G of CD upon IP of CD. Great. Enjoying or not? Simply. It is very simple na yaar. Enjoying or not? Phi DE. Cut a section like that. See from left or right? Let us see from left, it is easy. Right is too much. Left it is easy. TE coming inside. So plus L4 G of DE and IP of DE. Everybody please let me know, have you understood this or not? Everybody. Chandan sir, no, Chandan sir is not there, and might be your earlier things are also correct. I am not saying that if you want to change the name, that means earlier will not be correct. Earlier can be this. Have you got it? This, put a heart sign if you got this, guys, and everybody please like the session. Have you got this? Everybody please let me know. Please let me know, have you got this or not? Okay, just let us finish bars in parallel also, then we'll be coming to the sir. This is one bar. Let me make with another color. One, and that is second bar. Okay, let me just make it second. Okay, so this cross section, if I draw the cross section, then you will get it. This is first one, and that is second one. And that is first one. Okay, that is first one here, and some torque is applied. So guys, see. Suppose I apply a force. No, Joshi sir is gone now. Suppose I apply a force. इसके बाद. Suppose I apply a force. So I apply P force. So it is absorbing P1, it is absorbing P2. What is P1 I don't know. What is P2 I don't know. But I know this, if I am applying a P force, then it is having P1, it is having P2. So P1 plus P2 is equal to P. If I am applying P force in these two fingers. What is this? I don't know. What is this? I don't know. But if it is having P1 force, if it is having P2 force, so P1 plus P2 is equal to P. So out of T torque, something is going in 1, something is going in 2, but total will be equal to torque T. Okay, I am applying total torque T. 1 is absorbing T1, 2 is absorbing T2, so T1 plus T2 is equal to T. And since it is connected by a rigid plate, and rigid plate will be like this, and it can go like this. It cannot, if rigid plate is like this, it cannot bend it like this. No, that is rigid. So twist will be same. Either you calculate phi here, twist will be same. So twist will be same. So phi 1 is equal to phi 2 for parallel connection. So phi 1 is equal to, what is T1 into length upon G1 IP1, and for second T2 into L G2 IP2. Two equations you have, two unknowns, T1 and T2 can be find out. Got it or not? Everybody got it or not? And what was my trick? That is not very interesting trick might be. See, whatever sometimes some beam is there and some deflection is asked at any point. Some loading is also given. So this is A. Suppose deflection is B is asked, and you don't know how to calculate, but you know deflection of C by standard formula if the loading is such. So deflection will be smaller. Suppose B is here, B will be smaller. So with this you can eliminate couple of options in the options if they are higher than C. So many such questions you can eliminate. Something is asked and you don't know the value of that thing, but you know the maximum value, so that will be smaller. Similarly in the case of shear stress, suppose you know tau max, that is sigma 1 minus sigma by 2, that is radius of Mohr circle, and shear at 30 degrees is asked. So if you are not remembering the formula, if you are not able to solve the value of shear stress at 30 degree location, just find tau max. Tau max is easy, sigma 1 minus sigma 2 by 2, and that whatever tau is asked at any other angle, that will be smaller. Same thing can be applied not only deflection and torsion, but it can be asked, it can be applied in hydrology as well. Infiltration it can be used. Okay, that infiltration will be less than rainfall intensity. Whatever rain is coming, infiltration will be less than that. Or in Horton's curve, it will be less than the initial value, infiltration capacity. Okay, so now I welcome sir to talk to you for motivation at the last time, because last time not only the concept but motivation is also required to charge.
Hello everyone, how are you all? How's your energy everyone? How is your energy guys? I hope you are all super excited and super energetic and attending the strength of material sessions very sincerely everyone. Welcome everyone. A very good afternoon to all. A very interesting problem sir is discussing over here, I was looking at, and this rigid plate over here is trying to make this system work together, due to which the force is shared, right? Welcome guys, welcome. So sir, how are the students?
Students are fantastic. I'm not saying for their motivation, but really I find one thing sir, that in BYJU'S Exam Prep, whether Hindi channel or GATE channel, whenever I'm giving the questions and they are solving, I not for their sake, not for their motivation, but how the students are of top quality in this channel.
Yeah, right.
The competition is very good here.
Definitely sir. Definitely. Yeah, my voice is low. So guys, strength of material weightage is, as you all know, is very high. Okay, so these are some of the topics which are very frequently asked, right? So make sure that you prepare all these topics and prepare all the concepts that sir is explaining right now, because the question is going to be asked from here only. And a similar kind of concept, very easy, very straightforward. All you need to know is remember all the steps that are told by Abhinav Negi sir, right? So continue with the session, everyone, and I'll be coming back.
Somebody also wants to know the important topics of SOM. If you can just tell them couple of topics or 3-4 topics of SOM.
Strength of material, first chapter is actually, if you look at the previous year questions, strength of material from each and every chapter, few questions have been asked. Okay, the syllabus has always been covered, the full syllabus. There are a few topics which are not touched by gate examination. There are very few topics. Else, if you go to the deflection or bending stresses, shear stresses, torsion, and if you go for your axial strains, introduction chapter, everywhere strength of material is distribution is always uniform. Okay, you can skip a few concepts if you are having some time issue. You can view some concepts from like thin tubes, right? From there very rarely a question is asked, and that question is somewhat like a conventional based question, right? You can skip springs if you are not able to remember the formula, although I will prefer to, it is only few pages only. So if you go through that chapter, if one question is asked, you will definitely be able to make that question, and that question is going to be straightforward, right? So there are few topics which do not require much effort, but all you just require is to remember the formulas. So you can go through those chapters as well. Okay. Anything else, guys? Anything you would like to ask? Very good, very good. Click on like button, everyone, and share the session and make this a session successful, guys.
Okay, thank you, sir. Thank you so much. Okay, so everybody is coming here to motivate you guys. That shows the team effort, that shows the dedication, and I not only our dedication but your dedication, that watching me live here, then Joshi sir FM session, then my 8:15 PM session of MSQ in Hindi channel, and then Menti War. Okay, so guys, not only taking classes, but we have to make PPTs as well. We have to do some other official work as well, and it's effort from not only our side. We are doing our effort, but your effort is also we have seen it's tremendous. The tremendous response that you have given us, that always motivate me to, or motivate us to do more better in the coming future. Okay, guys. Okay, so please do this question. A hollow shaft of 60 mm outer diameter and rotating 25 hertz. So take it assignment. I will share the solution in my Telegram of the questions. Okay? Okay, question. Not wasting time in question, because actually, guys, see, marathon will be 5 hours. Part 1 3, part 2 3 hours, or part 1 was 2.5, part 2 will be of 2 hours. But of course, to be very genuine with you, to be very frank with you, each and every derivation can't be done here. I'm accepting this, because in the courses we are teaching it 80 hours, 70 hours, 60 hours, 90 hours. Of course, that 80 hours marathon will not be as useful, because it will be very difficult for you to continue the maintain for such long hours for so many days. That's why this is a concise way, like I myself admitting that I have left the strain rosette part. Okay, because I find that is not very important, that this year it will be asked. But yes, always the stress part is important of transformation, not the strain. I'm not saying that strain can't be asked. It can be asked, but more chances are of transformation of stress, Mohr circle for stress, rather than Mohr circle for strain, or transformation of strain or strain rosette. Zero I'm not saying, but chances of stress are more. Okay, now let us come to the column chapter. Okay, so PCR is equal to the critical load from which the column will buckle is equal to n square, and that is having a derivation. If you have studied from me in the vision courses, I have done the complete derivation of this from differential equation. Of course, I'm not wasting time of yours here in derivation. N is the number of buckling loops. You understood not this formula as well. Pi square EI upon L square, L effective square. Okay, actual formula is this that I derived. Okay, So n can be 1, can be 2, can be 3. But in our courses, n is always 1 because there are only 2 supports. So we assume this formula. L effective for fixed case is how much? L by 2. For both side pin, it is how much? L. It is the distance between the 2 points of contraflexure. Okay, when one is fixed, one is free, it is 2L. When one is fixed, one is pinned, it is L by root 2. L by root 2 hota na? Like this. Okay. So now for n is equal to 1, PCR is equal to pi square EI upon L square. Okay. Now there is a term radius of gyration, and A into R minimum square is equal to I. Okay. A into R minimum. So I you can replace by I, actually there is I minimum. A into R minimum square. Okay. And if I put R minimum square at the bottom, so it will be R minimum ka square, and lambda is this slenderness ratio. What is the feeling of slenderness ratio? What is the feeling of slenderness ratio? If more is the lambda, more will be the long column, means more chances of buckling failure. And if lambda is smaller, that is short column, more chances of not buckle, more chances of crushing. See the scale that you used in your 8th class, that steel scale of 30 centimeter, from where sometimes teacher beat us also. That scale if you push now, it will buckle, not crushed. That will be buckle, not crush. Now suppose I take this marker, this is short, that was long column. So if you put 30 centimeter scale, it will buckle. But this is a marker. And if you apply the load here, then it's more chances of crushing. It will be crushed, chakna chur ho jayega. Okay. So long column, usually lambda greater than 80. Lambda greater than 80 or 90, that is long column. More chances of buckling failure.
Sir, I would like to add one concept.
Of course.
Over here, one MSQ question I would like to point out over here. One MSQ question is over here. No, it's fine over here only. Okay. 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 So I would like to point out one MSQ question over here. See, if it is asked a question, what does critical buckling load of a column depends on? It's an MSQ question. Okay, let me. And the options are axial rigidity, flexural rigidity, torsional rigidity, and slenderness ratio. Tell me what is the answer. It is a multiple select type questions. More than one options are correct. Tell me what is the answer, guys. Everyone, tell me what is the answer. More than one options are correct. A, B, C, D. So if you go through the formulas, sir, previous slide karna iski. So if you see the formula, we have flexural rigidity over here, EI is over here, axial rigidity is over here, AE, and we have slenderness ratio. But GJ is nowhere. The torsional rigidity. The torsional rigidity is nowhere. So the answer is A, B, and D. Torsional rigidity is not the answer. So it is a very good and very conceptual question, and this kind of question can be asked. Thank you.
Okay, guys. So I hope you like it. A and D.
A, B, D.
A, B and D. Okay. So, thank you, sir. Now guys, Rankine, never the question has been asked, but if you want to know that Rankine load of failure is 1 upon P, that is Rankine load of failure, let me write PR, 1 upon crushing load plus 1 upon Euler's load. Euler's load is this is 1 upon Euler's load, but never the question is asked from this, so not much required for practice. Now spring, this is the closed coil spring, okay, whatever the spring you have seen, that is closed coil spring. And when I apply the load on this, P, then strain energy stored is equal to 32 P square R cube into N into GD की power 4. Strain energy when I apply the loading. The strain energy is given by this. 32 P square R cube into N by GD की power 4. What is P? Load applied. What is P? The load applied on this. Okay, what is R? From center to this outermost distance R. N is the number of turns. P you know, R you know, N you know. G is shear modulus of this material. And D is this thickness. Now according to strain energy, what is deflection? Deflection is del U by del P. So deflection is del U by del P is equal to 64 P R cube into N by G into D की power 4. Okay. Now what is stiffness? What approx? What is, okay, Rakesh sir is here. 2-minute motivation. Rakesh sir is here, guys. Come on, like.
Let it be. Here, sir, mic. That is the one only. So guys, how is the revision going on? So all civil champions, anyways, the Don sir is taking the class, the revision will be in the full josh. But sir, across all branches I am seeing today attendance, suddenly day 2 May, there is a dip. So what sort of motivation students are having, we are not able to understand. In every type of situation, whether health is fine or unfine, faculties are taking the marathon day and night. You know, Abhinav sir, you know, session got cancelled at 10:30, mic issue at home. Suddenly sir will rush to the office. Still sir is coming live. So guys, that motivation, of course sir, एक चीज ये भी है कि जिन लोग के अंदर वो मोटिवेशन है वही गेट के टॉपर्स भी होने वाले हैं, बिकॉज फॉर्म्स, गाइस ऑलवेज रिमेंबर दोज हु आर लाइव, फॉर्म्स लाखों लोग भरेंगे, नंबर ऑफ एप्लीकेंट्स में भी इन लैक्स फॉर सिविल में तो होता ही है 1 लाख, मतलब मिनिमम 1 से ऊपर तो एवरी टाइम यू विल सी इन द पास्ट 5-7 years. बट हाउ मेनी विल बी द टॉपर्स? वेरी फ्यू, राइट? मे बी यू आर दोज फ्यू, राइट? सो इट डज नॉट मैटर हाउ मेनी स्टार्टेड, it will always matter how many will end the race. So I hope you will end the race. Still 1 more month to go. Civil is next weekend, second weekend, this time.
Civil is second weekend.
So you have 1 month and 1 more week
12th.
to go, right? And I hope you are all aware, admit card is now coming on 7th January. Okay, it was supposed to come on 3rd January, 7th January aega, but don't worry. See, IIT has announced 7th January as admit card date, तो सोच समझ के दिया होगा. They don't have anything in the mind that it is going to be postponed or something. Some students are having the doubt, na. But if they are, otherwise they will not give the date also 7 January, na. So if they have given कि 7 January admit card आएगा, so possibly, okay, we don't expect any postponed. Keep preparing, keep learning hard.
Okay. And in fact now we both might be corona positive due to the symptoms that we are having.
Right.
Okay. 2 minute काम है.
हाँ,
एक question देके आ जाऊँ.
हाँ, just question.
Guys, I'm just giving you a question and Rohan sir can get you the answer, and then I'm just coming in 5 minutes. Okay. So 2 minutes, sir. So that U is equal to delta is this. What is the stiffness? Stiffness is P by delta. So P by delta is G D की power 4 64 into P by delta GD4 64 R cube into N. Now guys, please see from here, K is directly proportional to 1 by N. Suppose I cut this spring like this, 2 parts, 2 equal parts. Material will not change, G will not change, material will not change, D is also not changing. If I cut the spring in 2 parts, G, material not changing, G not changing, D not changing, 64 not changing, R is not changing. For this part also R is this, for this part also R is this. What is changing? N number of tons. If I cut in 2 equal parts, stiffness will be doubled because N will be half. And guys, just feel, a long spring, same spring long, you can elongate it easily. But same spring, if it is half, it is difficult to elongate. Stiffness will be more, with number of tons will be less. Okay. So this all we have done. What is K equivalent in series? Opposite of resistance that we studied in 12th class. 1 upon K1 plus 1 upon K2 and so on. And what is in parallel? K equivalent is K1 plus K2 and like this. Parallel means deflection same. Deflection same. If I put it here, deflection same. Series means load is same. If I applied P load here, P will be transferred here, P will be transferred here. Now you have to find K equivalent of this. Now if you have to find K equivalent of this, and Rohan sir will guide you for 5 minutes for some more tips and some more tips of SOM only. Okay. I'm just coming in 5 minutes. Rakesh sir has some work with me. Okay. I'm just coming in 5 minutes, guys. I promise. Stay tuned, everybody.
See, it's been a while since I have taught strength of material, but I will try to continue. Okay. Okay, guys. So today I came in my normal uniform only. I was not having any class today, but since I'm in front of you and I love to teach you guys, and let us see the question. Okay. Now we see over here that we have a system of springs. A system of springs is over here, and we see that few of the springs are in series and few of the springs are in parallel, right? So if we see, as the Abhinav sir has already told, if the springs are in series, then K equivalent is the harmonic mean, whereas if the series are in parallel, then it is just the addition, right? So over here we are having these three in series, so it will be 3K over here. Sorry, these are in series and these are in parallel, so it will be 1 by K equivalent for only this portion. Let us call this as portion number 1. So K equivalent of 1, okay, is equal to 1 by K plus 1 by K plus 1 by K, which is equal to 3 by K. So K equivalent for this one system will be equal to K by 3. Yes or no, everyone? Yes or no? And similarly, if this is K by 3, this will also be K by 3. And this will also be K by 3. And now these three we are having, you can assume that these three are springs having a stiffness of K by 3 each. So what will be and all these three springs are in parallel. And for the parallel, your K equivalent, let us call this whole as 2. Let us call this whole as 2. Now the K equivalent for 2 is equal to K by 3 plus K by 3 plus K by 3, which is equal to again 3 times K by 3, which is equal to K itself again. So the stiffness of this whole system over here is how much? K. Now what are we having is, we are having one spring like this whose stiffness is K, and a spring like this whose stiffness is K by 2 and K by 2, and another spring like this, a load is applied over here and the stiffness of this particular spring is K over here. So these two are again in parallel. So what will be the total stiffness of these two? It will be K by 2 plus K by 2, which is again K. So I can erase this over here and I can make this as K. Yes or no, everyone? These two, the stiffness of these two springs over here is K, right? And these are three springs which are in series. So for this, 1 by K plus 1 by K plus 1 by K, which is equal to 3 by K, which is 1 by K equivalent. So the K equivalent, this implies that your K equivalent is equal to K by 3. Any doubt to anyone? Any doubt, guys? Any doubt, anyone? Is it clear to all? Excellent, guys, excellent. Now let us discuss today. Actually I can see that the strength of the students have reduced, right? Only very few students are here, and a lot of students are currently taking rest or something, or rather we can say they are demotivated, that they have not studied anything at all. let me tell you, my friends, if you have been giving your best, if you have been preparing up till now, okay, see, your time is not free, right? Your time have some value, okay? So if you have invested at even 3 to 4 hours every day, or if you have prepared to some extent, so make sure that preparation counts. This last 40 days, they are very, very important. This last 40 days, what if you give your best right now, forget anything, forget each and everything that is there around you, isolate yourself.
Productivity of 80 days of June, July, 80 days.
I would say that it will make a difference, a huge difference it will make, right? So just isolate yourself, tell each and every person around you to do not disturb you, okay? And make sure that just don't get out of the room at all. Study the whole day, you just keep on studying. Go through all the previous year questions, go through all the concepts, try to remember as many formulas as you can. This is your time, guys. This 40 days can make a difference, my friends. I can assure you that. I have a friend of mine during when I was studying, and that guy has not studied at all, okay? During my college times, my friends, they started preparing, and that student started preparing only 2 months before the examination. And in that particular 2 months, although he did not want to go into very deep concepts, but he wanted to brush up each and everything. He wanted to remember all the formulas. What he did is, he took each and every subject and he saw the previous year questions. If one formula is asked, related to that formula, whatever are the important points, he noted it down. Then again, whatever the question is asked, whatever the formula is asked, whatever the concepts, he noted it down. And like this, he prepared each and every subject within 2 to 3 days. Like this, he got a rank of, believe me, my friends, 1200 All India rank.
Adon, please share the session everywhere.
I know it is not very good rank, but after 2 months of preparation, this rank is not bad. He was getting an IIT for MTech. He was getting an IIT, although he prepared again and he got an All India rank of less than 100, right? But still, with 2 months of preparation, this is not bad. All you require is dedication. So so start studying if you are lagging behind, okay? Tie up your boots and believe in yourself, guys. It is very important to believe in yourself, okay? If you do not believe in yourself, you will not be able to do anything in your life. Believing in yourself is most important, okay? Clear, guys? So do you guys believe in yourself? Aim for the best, guys. Your time is precious. If you are investing today, it should bear some results tomorrow. Your time is very, very precious. Do you believe in yourself? Yes or no, everyone? I want to hear yes from each and every one of you. Quickly comment in the chat section, guys. Do you guys believe in yourself? You can do anything you wish for. You can achieve anything you wish for. Yes or no, guys? Yes or no, everyone? I want full Josh. Excellent, excellent. Shantu, Aman, Star, very good, very good. Abhishek. Excellent, excellent. Ritu, Nantha, Suraj. Excellent, guys, excellent.
And sir, one more question, guys. Just let us know that how this session is helping you. Is it helping you in revision way? Is it helping you in getting the concepts? Just want to know that how it is helping you.
Yes, tell guys, how is this session exactly helping you?
Brushing the concept, getting the concepts, or you have some concepts you are knowing first time. In which way? In revision way it is helping you, in getting the concepts way it is helping you. In getting the concept is helping you, in revision way it is helping you. Please let us know. And like it, yaar, come on, guys. Sir? Okay, guys. Thank you. Okay, just let me wear the mic. Both. Great. Okay. Both concept and revision wise. Okay. So we have you done this? Oh, K. Kurun sir has done, yeah. K by 3. Okay. Guys, now what is shear center? Guys, shear center, only one question has been asked till now. That what is shear center? Shear center is that point through which if load passes. Shear center is that if load passes from that point, then guys, there will be no bending. Okay? There is no shear center is the point through which if there is load passes, then there is no twisting. Sorry. Then there will be no twisting. Okay? See, suppose this is a shaft. So if you apply load like this, yes, it can twist. It can twist if you apply load like this. But if you apply load like this at center, exactly at the center, it will be compressed. There will be no twisting. Hey? Okay. So then there will be no twisting. Okay? So shear center is that point through which if load passes, there will be no twisting. What are these rules? I am explaining you here. Don't read them, I will explain you here. Guys, shear center always lies on the axis of symmetry. So this is the axis of symmetry. Okay, guys, see here, these all points I am explaining you here, and this is also axis of symmetry. So shear center will be here because shear center lies on axis of symmetry. So first point was it lies on axis of symmetry. Second point was if there are more than one axis of symmetry, it will lie on junction. It will lie on the intersection of symmetrical axis. So intersection is like this. Similarly, shear center is like this is symmetrical axis. This is also symmetrical axis. So shear center will be lying here. Shear center will be lying here. Now the third point. Third point, guys. Yes, I have seen the comments. Now shear center will be here at the intersection symmetric of this, and third point is this. If there is section is made up of two narrow rectangles, the shear center will be like this on the intersection of the two rectangles. So here the symmetrical axis of this rectangle, here is the symmetrical axis of this rectangle, this will be the shear center. This is the third point. And some other values that you have to remember. Of course, you can calculate it from the long derivation, but that is not at all required for GATE and ESC both. Otherwise, I will complete shear center in 3 hours here, deriving all these values. But that is not at all required for GATE or any other objective exam. Not even in ESC subjective, they will be asking you the derivation of these shear centers. So shear center, always you have to learn only two things. First, that if load passes through shear center, there will be no twisting. However, bending may or may not occur. No twisting. And second is these points to locate the shear center. Okay. So combined stress we have done yesterday. Come on here. This na, when movement is also acting and load is also acting. Bending stress after I told you. That will be algebraic summation. Due to this find the bending stresses. Due to this find the axial stresses, and that will be the thing. Now pressure vessels. Guys, suppose there is a cylinder, and cylinder if some gas is filled with P pressure. In cylinder the gas is filled with P pressure. Then there will be stresses. Come on. If there is a cylinder I fill with gases, then the stresses will be coming inside in the membrane, in the member. Okay. So when the stresses will be coming here, then if I cut this like this, okay, and if I see by cutting it, it will be looking like this. So these stresses are hoop stresses. These stresses are hoop stresses. Why the stresses will be coming? I already told you here. If you fill any bottle with pressure inside, there will be stresses. So this will be hoop stress, and this will be, there will be longitudinal stress. This red one. Okay. And what is the pressure inside? That is radial pressure. So if you feel this, the longitudinal stress, whenever I fill the gas inside, this longitudinal stress will increase the length. Longitudinal stress is increasing the length. Longitudinal stress is increasing the length here. Okay, this is increasing the length. And hoop stress is increasing the diameter. It will be more, making it more bigger, more diameter. Okay. So here I am not going in derivation. sigma L is equal to PD by 4T and hoop stress is equal to PD by 2T. Now what is F's hoop strain? Of course here, very easy with Poisson ratio. It will be sigma H by E minus mu sigma L by E, you can calculate. Similarly, longitudinal strain will be sigma L by E minus mu sigma H by E. Okay? And what is the change in volume? Because we are studying deformable physics. So volume change will be equal to P for 2D case PD by 4TE into 5 minus 4 mu. And if you are going for 3D, then you have to add one more term, 3 mu P by E. 3 mu P by E. Then one more term is added. What is the maximum stress? Tau max. Tau max is sigma 1 minus sigma 2 by 2. Tau max is sigma 1 minus sigma 2 by 2. So tau max is equal to sigma x minus sigma 1 minus sigma 2 by 2. They are principal stresses. So it will be PD by 80. And tau max in 3D case is equal to, see in 3D case. In 3D case, tau max is equal to maximum of sigma 1 minus sigma 2 by 2, comma, sigma 2 minus sigma 3 by 2, comma, sigma 3 minus sigma 1 by 2. Sigma 1 is this, sigma 2 is this, sigma 3 is actually this radial pressure, which can be neglected because in terms of these value, P is very, very less. Sir, why less? Why less? Because see, in denominator it is T and T is very, very less than D. Thin cylinders. T is very, very less. So sigma L and sigma H are very bigger in comparison of B. Again I am representing. Why I can neglect P? Because denominator T. So T is very less. So sigma L and sigma H are very big than P. So in comparison of sigma L and sigma H, P can be neglected. So one sigma 1 is this, sigma 2 is this, sigma 3 is 0. Sigma 1 is this, sigma 2 is this, sigma 3 is 0, and if you apply for absolute case, that is 3D, absolute means 3D. It is PD by 40. Everybody please let me know, have you got it or not? Everybody please let me know, have you got it or not? Any doubt, please ask me. Okay, similarly for this we have done, all we have done this. Shear stress we have done. Sphere, it is symmetrical. So sigma H is equal to sigma L is equal to PD by 40 and epsilon H is equal to epsilon L with the same concept that we have done earlier. It will be PD by 40E, PD by 40E into 1 minus mu. And tau max here, guys, you can find with the same concept, and volumetric strain here will be 3 times of this. 3 epsilon H, that will be the volumetric strain. That will be the volumetric strain. Everybody, any doubt, please let me know. Guys, think I am not doing here because that is not important. Think I am not doing here, it is not very important. If you ask me, I will make a 5-minute video for you in Telegram, Civil by Abhinav sir. I will make a 5-minute video for you in Telegram, Civil by Abhinav sir, okay? For thick. Now the last chapter, deflection. Are you ready for this? Are you ready for this, guys? Last chapter, deflection. Please let me know. Please let me know. Okay, so there are some standard results, of course, that I'll give you in PDF. These are some standard results. First one is double integration method. How to use this, let me tell you. Weightage of SOM, yeah, around 7 to 8 marks it can be asked maximum. So double integration method, see, it says that d2y by dx2 is m by ei. Sir, how this? Sir, how this? Guys, see the beam above your head. See the beam above your head. Deflect, slope, every beam you are thinking as straight. So dy by dx is almost 0. This is 0. So 1 ki power 3 by 2 is 1 only. So simplified form is like this. Simplified form is like this. Okay, so dy by dx is almost 0 because beam is almost straight. All beams above your head is almost straight. So what you do in such cases, how to solve that? Whenever load is given to you, suppose length is L, this is E, this is I, just take a section here. What is bending moment here? What is bending moment here? P into X, hogging. Apply in this formula. d2y by dx2 is equal to m is minus px upon ei. Then integrate it. It will be dy by dx, that is slope. That is slope. You can find slope from there. Again integrate, that is y. Y is deflection. Of course, with integration, one constant will be added. Then with boundary condition that x is equal to L, deflection is 0 or slope is 0, you can find it. Got it, everybody? Got it, everybody? Got it, everybody? Please let me know. Please let me know. Any doubt to any one of you? Any doubt to any one of you? Okay. Now area moment theorem, guys, he says that first of all make a M diagram. This bending moment diagram, here it will be PL. Make M by EI, divide by EI. So 0 by EI will be 0 and here it will be like this. Okay. Then the difference in slope between any 2 points like theta B minus theta A, first theorem. Theta B minus theta A, first theorem. Sir, आप जाओ, हम 10 मिनट में आ रहे हैं. Theta B minus theta A is equal to area between them. Area between them is this one. So area, this is half base into height, and theta A is fixed, it is 0. So theta B is equal to PL square by 2EI. So what is the first theorem says? That difference in slope between any 2 points, difference in slope between any 2 points is area between them. Any doubt, please let me know, yaar. Come on, friends. Okay. Sir, what is the second point? What is the second point? Second is deflection of B with respect to tangent at A. So tangent, see, slope is 0, so tangent is this. So this is called deflection of B with respect to tangent at A, and it is actually delta B only for this case. It is actually delta B because tangent at A is like this. Slope is 0 there. So deflection of B with respect to tangent at A, for above case it is exactly delta B, is equal to movement of area. What is area? Area is this. About the point where deflection is required. That is B. So movement of area is this. Area can be concentrated at center of mass. And here the distance is 2L by 3. So movement of area means movement is force into distance. Moment of area is area into distance about this point. That is 2L by 3. So it is PL cube by 3I. Got it, guys? Got it, guys? Okay. Next is this theorem 1 and 2 I have discussed. Conjugate beam is little bit easy, but calculation wise little bit tougher. It says make a given beam is this. First step, make it BMD, M diagram. M diagram means, you know, yesterday I told you how to make BMD. You can draw BMD. Second, make M by EI diagram. You know M by EI diagram, divide by EI. Like here it was M PL. So M by EI will divide by EI. So make M. First step is make the M diagram. Some loading will be given, na? Make the M diagram, then M by EI diagram. Then third, whatever is the M by EI diagram, put it as loading diagram in conjugate beam. Loading diagram in conjugate beam. Then fourth step, whatever is the shear force in the conjugate beam, that is the slope in the real beam. Whatever is the bending moment in the conjugate beam at any point, that is the deflection in the real beam. Everything here is written. I will give you PDF in my Telegram, Civil by Abhinav sir. Now, nothing you have understood. Let me tell you example. Then you will understood everything. First of all, conjugate beam of this will be like this. Conjugate of beam will be like this. Fixed will change to free, free will change to fixed. Fixed will change to free, internal hinge will be changed to internal roller will be changed to internal hinge. Free will be changed to fixed. Now nothing you have understood. I know. Let me tell you example. Suppose this is the question. Length is L, E, I, B, A. This is a real beam. Real beam means that is question. Question given to you is real beam. Make the first step was make the M diagram. So bending moment diagram is like this. First step. Second step was make the M by EI diagram. So M by EI will be like this. Divide by EI. Okay. Third step is put M by EI diagram as loading diagram in conjugate beam. So conjugate beam of this will be like this. Fixed will be free, free will be fixed. This is conjugate beam. Now put this loading diagram here. Put this loading diagram here as loading M by EI diagram as loading diagram. Control X, Control V. Control X, Control V. So put here as loading diagram. What is M by EI? Now this is B. Whatever is the shear force in the conjugate beam, that will be the slope at the real beam. Slope at the real beam. So shear force here will be the force. Total load is UDL, M by EI per meter. So in L length it will be this. This will be theta. Theta in the real beam. Whatever is the movement here, bending moment. Bending moment is total load is this into L by 2 is equal to deflection of real beam. So ML square by 2EI. So it is very easy. The only difference is that calculation might be easier for this case, but when the M by EI diagram is parabolic, then in that case you cannot find the shear force of the parabolic loading or the bending moment of the parabolic loading. It will be difficult in that cases. Got it or not? That is total strain energy, guys. I totally recommend you all that for strain energy, guys, I don't want to do in this marathon. Literally saying this. Strain energy, there are many of my videos in Hindi channel, in English channel also. Please see that video. That is must for everybody. Today there are so many classes of you. Like 8:15 PM I am coming with this MSQ series. Okay. So today not, but any soon, whenever you will be getting time, please see that session. Please see that session of, because that is why I am saying now that is important, because most of the questions you can solve from strain energy. Anybody please share my MSQ link here. Okay, so strain energy complete. I don't want to do in this revision mode. Strain energy should be complete concept from 0 to infinity. Please see my video of that. Okay, will you see it within next 3-4 days? I think tomorrow you will be having less classes. So strain energy, literally guys, that is a topic that I don't want to discuss here in the revision mode, that you have to study from 0 to infinity. That much is importance. Why? Because strain energy can be used everywhere. Whether the beam is prismatic, not prismatic, you can use. Whether the internal hinge you can use. Whether it is n number of supports are 5, you can use. Okay, so everything has a limitation. Let's see. Let me tell you limitations as well. Double integration method can be used only for prismatic beams. Means if this is IE and this is 2IE, you cannot use double integration. Area moment theorem you can use for prismatic, non-prismatic both, but it is suitable for cantilever because zero slope should be known, because slope theorem says theta minus theta A is equal to area of M by EI. But one of the theta has to be 0, then only you will find theta, na? Otherwise it will be one equation, two unknown. So cantilever or symmetrical simply supported, because symmetrical simply supported beams like this, deflection at the slope at the center is 0. Otherwise it will be two equations, one equation, two unknown. Theta B minus theta is equal to area. Area you can find out, but what about two unknowns? So one has to be 0. So limitation of area moment theorem is it will be only used where theta is 0, you can be finding out. Okay, similarly conjugate beam is calculative. Okay, when the MD bending moment diagram will be parabolic, then you control X, control V. That parabolic BMD to the loading of conjugate beam, it will be very difficult to find out. So in that case, guys, every time I must recommend a strain energy. I am not teaching you here. Okay, Joshit sir? Because strain energy is so much significance. It can be used in prismatic, non-prismatic. It can be used when there is no discontinuity. Everywhere it can be used. So it's better to see my whole lectures in Hindi and English channel. No. Okay, so that's why, guys, now here. Sir, iska link share kar denge aap ek baar comment mein. Everybody please like it now. Now whole team has done effort from November 15, last 45 days to make the MSQ questions. 8:15 PM on Hindi channel. Joshi sir is sharing the link. Like it right away now. And sir, apna bhi share kar do 5 PM wala. And Joshi sir is having 5 PM session here itself in English channel. Today, FM2. Joshi sir is sharing both. Please like the both sessions, guys. And this PDF I will be sharing in my Telegram just in 2 minutes. Civil by Abhinav sir. In civil by Abhinav sir, I'm sharing it in 2 minutes, guys. Okay, please tell me, guys, how you like the session. Was it benefited? Give me frank, and what I can improve more. Please like both the sessions that Joshi sir has given you, and please tell me frankly, guys. Joshi sir, please आइए ना. Please tell me frankly what I can or we can improve more in the upcoming marathons like soil, SOM, hydrology, environment, all these. Please tell us, yaar. To be very frank, should I bring more numericals? Please, guys, because we are here putting our energy, our effort for you only. So what you want more, please tell us. Please tell us, guys. So that will be bringing more in the upcoming sessions.
Hanji, so guys, please let us know if you need anything else anything else that you were expecting कि नहीं sir, we were expecting something else. You are, please, you can say you have that बोलते हैं ना हक, पूरा हक के साथ you can ask for it, ठीक है? So please let us know if you need anything. And now I have shared the link for both the session. One session will be at 5 p.m. and that will be the fluid mechanics part 2. For both students, mechanical, civil, both can join that. And then we have session at 8:15, 8:15, right sir? For MSQ on the Hindi's YouTube channel, right, of BYJU'S Exam Prep. Do not forget to subscribe it अगर अभी तक आपने नहीं किया उसको. And then again we'll come back with the Minty quiz, and that I'll be sharing the link with you again in the Telegram group. Please join Civil by Abhinav sir Telegram group. He is going to provide you all the PDF of this session, and I'll be providing my in Civil by Ninja sir, that I'll give you in the 5 p.m. session also. अब सर एक बार लिंक भी डाल देंगे आपको Telegram का, so that you can join it and you can download the PDF. And with the PDF we will also provide you the link of this session. That will be important, right?
Please give us suggestions, yaar. What we should bring
more suggestions, please. More suggestions.
Like Abhishek Rawat has given a nice suggestion. I'll take it.
Correct.
More
correct.
suggestions I want.
Okay, so very important numerical concept, right? So what we have already planned is, मैं वो बता देता हूँ, so that you can give us more effective suggestions as well. So we are giving you like today you are done with the SOM, right? And that is the reason why today only, not yesterday, today only you are having the MSQ session of the same subject, correct? So you are going to get benefited out of this particular session. And remember, when you solve MSQ, in every question you learn more than one concept. That is the best thing about MSQs. Okay? So that is the thing. Where I can get mechanical. Mechanical classes are also going on here only, right?
Hindi also MSQ is going on for mechanical.
Yes, mechanical and ECE, EE and civil, all of the sub branches are going to be having the MSQ session on the Hindi channel itself. Okay, sir? So please ask if you have anything else, or if possible कल SOM marathon में जो question थे उसके solution भेज देंगे 100%. If possible, that is considered it done, please. Okay. All right, more numerical, ठीक है. So this is the one suggestion that I'm thinking that is going to be very, very useful for us also and for you also. Apart from this, what we can add in this session, you can also let us know if any other type of session you are requiring right now, as per the condition, as per the situation that you are being going through. Please let us know. And remember, one more complete numerical session of every subject is going to be conducted, and to save your time, to make it more effective, we are going to conduct it in one go. In one session, we'll be doing all the subjects, so that you don't have to wait for all the subjects. एक session में मतलब what you can do is you can download that video and you can just revise whenever you want. If you are that type of person who want to revise things when you are going to the exam hall or before the exam, you can simply just watch that video in 2x or 1.5x to revise all the formulas of every subject, right? And you can also what we will do, we will add the timestamp as well. So timestamp में what you can do, you will be able to just jump directly onto that subject whose formula you want to revise. If you want to revise, for example, SOM, you just go to description, click on the SOM, right? And you will be able to find that out, right? Okay, Kalida says, thank you for the time and effort. It helped me a lot. Thank you. Gain more confidence. Amazing. Great. Perfect. So let's now close the session, and I hope we'll be meeting again at 5 p.m. with fluid mechanics remaining portion. All right, sir?
Thank you, guys. Take care.
Thank you. Bye-bye. Take care. We'll see you soon. Thank you.